rising due east is then perpendicular to the horizon?
No. It depends on your latitude on the Earth. So from our latitude in the northern hemisphere, basically anywhere, things are going to rise at an angle to the horizon. The only way that they are going to be perpendicular is if you're on the equator.
So they can. Is Orion up for 12 hours?
Approximately.
Like always, year round?
Yeah, approximately. But as we'll see in the second part of the yearly motions, sometimes those 12 hours are during the day.
Right, but I'm just thinking like, so at some times of the year it might be more vertical on rising and setting.
No. It's always going to make the same motion. It's going to make the same motion.
Regardless of the time of year?
Yeah.
What about things that are rising southeast?
Same.
There are things that like, and sometimes of the year they barely come above the horizon, and then later it's on like.
No, they're all going to make the same motion. It's just that that motion may or may not be during daytime hours. That's all. So sometimes constellations are not visible to us because they are above the horizon during the day. And Orion's a great example of that. Orion's difficult to see sometimes of year because it's 12 hours or sometimes only daytime hours. But the motion itself is the same.
Yeah, maybe I'm thinking of the sun.
But we're only talking visible, like here. I mean, technically Orion would always be visible for 12 hours to like a radio telescope.
That's right. That's right. For a radio telescope, it doesn't matter. But if you wanted to observe Orion, you would point your telescope at a particular direction at different times of day throughout the year, because Orion will be at that location different times of day. So if we're talking about normal clock time, then it doesn't matter, but it is always above the horizon for 12 hours. So a radio telescope can always observe 12 hours.
So I'm thinking of the sun then. The sun doesn't make the same arc.
That's right. The sun doesn't.
Right, okay.
And that's because I don't have the right slide here. I'll bring this up later, but the Earth is tilted towards the sun different. I mean, we get different amounts of that tilt, yes. So it's a seasonal effect for the sun.
But because everything else is so far away, I guess when we revolve around the sun, our looking outward far away doesn't change.
Another way of thinking about it, actually I can do this on this slide. This is the sun's yearly motion about the celestial sphere. The celestial sphere itself is more or less entirely fixed. And that again, it's like you said, the distances are so large that any yearly motion is minuscule. That's called parallax, by the way, and the parallax is really, really, really small. Yeah. But the sun, if you notice, it moves quite a bit. And what you want to focus on is the fact that the sun moves with respect to the celestial equator. And this, the maximum offset between these two is 23.5 degrees.
Doesn't it change when the Earth is precessing, right?
The sun, yeah. The Earth's axis is precessing, yes.
And that's what's causing the 23-degree change, right?
No. So the precession is actually a 10,000 year cycle. And the 23.5-degree change is a yearly cycle. Because sometimes we're towards it, and sometimes away.
And so sometimes this yellow, the sun's orbit in this picture is coincident with the celestial equator.
twice a year
Okay,
That's the,
on the equinox. So
that's the
it's-
equinox?
right.
Yes, so this is one equinox, and then through the sphere on the other side is the other equinox. This is one solstice at the highest point, and this is the other solstice at the lowest point. So this would be summer solstice at highest, what's called declination, and this is winter solstice at lowest, what's called declination.
And these two tracks will never, I mean, it only changes in 10,000 years or something like that?
Yeah,
Okay.
they're stable. The exact calendar date for this intersection changes a very, very small amount, but the tracks themselves are stable. Yes. So, does that help with your question? That the sun
Yeah.
is moving relative to the stars, and that's why the solar motion throughout the year changes, whereas the stellar motion doesn't.
So at the equinox, is the sun rising due east then?
Yes, that's correct.
So in the summer, it's rising north of the east?
That's correct.
Wow, I always think of winter, right? For some reason I don't think of summer, but I do think of it as being more, yeah, I guess it is.
Yeah. So in the summer, the sun is doing, not obviously this from our vantage point, right? But it is rising more towards the northeast, and it is setting more towards the northwest, which is above the horizon for longer. Whereas in the winter, the sun is rising more towards the southeast and setting more towards the southwest. Days are shorter. I will be able to show this in more detail in the planetarium. But the solar motion, although it's super interesting, is not exactly the focus of this lecture. It's something I talk a lot about in 100 level class, but for you guys, because you are all now radio astronomers, you don't really care about the sun, except don't point your telescopes at the sun. That's really the only limit. But radio can observe all the time. You know, it can be hailing out, you can observe. It can be bright sunlight, you can observe. It doesn't really matter where the sun is to a radio astronomer, except again, don't point at the sun, it's real bright.